And the last one, we have to be able to prove triangles are congruent. All right, there's basically 4 steps to proving triangles congruent. The first step, right given, always. And I'd suggest doing a 2-column proof. Then, next step, show every single side is congruent to its corresponding side. You might have to use the reflexive property, definition of midpoint, so on and so forth. Next, show all angles are congruent to corresponding angles. You might have to use the alternate interior angles, alternate exterior angles, corresponding angles, consecutive interior angles, third angle theorem. There's a lot of different theorems we could use here, but you have to then show all the angles are congruent to their corresponding. And once you have the 3 sides matching up to 3 sides, 3 angles matching up to 3 angles, you just end with your congruence statement saying this triangle is congruent to that triangle. So these 4 steps are basically what we're going to be running through each time. Sometimes we'll have to do different things and it might not just be a 4-step proof. However, that's what we're going to do. So here's your example problem. We're given 3 sides are congruent and we're told one side is parallel to the other. AC is congruent to CE. Segment BC is congruent to segment CD. Segment AB is congruent to segment DE. And these segments, DE and AB, are parallel. That's the only one I meant to put in there. At this point, it's time to make the 2-column proof. Alright, now that I have the given written down, this is a step that you should always be able to get. You will notice that I did something slightly different than I have in maybe the past. I labeled SSS. They gave me 3 congruent sides, so I'm going to just put them all over to the side. 3 sets taken care of. Now all I need is angle, angle, angle. 3 more angles to be congruent. Now in my picture, if I look, I see that angle ACB, this angle right here, and angle DCE, this angle right here, well, those are vertical angles. So I'm going to say they are congruent. Angle ACB is congruent to angle DCE. And again, that reason is vertical angle congruence theorem. I'm going to write an A over here, and I'm going to do my next step. I still need to get 2 more angles. Alright, the next thing that we have to find here is the other 2 angles. So if I look here, this angle here is part of a parallel line. And in fact, it would be in the interior of these 2 parallel lines, just like this one. And they're on opposite sides of this transversal AE, segment AE. So therefore, these are alternate interior angles. And if the lines are parallel, alternate interior angles are congruent. So I'm going to say angle A is congruent to angle E. Similarly, I can make the same argument for angle B and for angle D. And I'm going to say, because they're alternate interior angles, and it's that particular theorem that allows me to say it. So now I look, I have another angle and another angle. I have 3 angles, 3 sides, all matching up. At this point, it's just as simple as saying the 2 triangles are congruent based on definition of congruent figures. Triangle ABC is congruent to triangle EDC. Well, if I look carefully, does angle A and angle E, are they congruent? Good. Angle B and angle D? Yep, they're the second letters. And last but not least, angle C and angle C? Perfect. They match up that way. Now how about segment AB and segment DE? Good, match up. Segment BC and segment CD? Those match up. And segment AC and segment CE match up. I have a good congruence statement. And again, that reasoning is definition of congruent figures. Well, there you have it. Those are the 4 new concepts. How to do a proof of this nature. The ones in sections 3 through 5 will be similar, but we're going to get shortcuts. Until we get those shortcuts, you have to show all 3 sides are congruent and all 3 angles are congruent. to their corresponding angles and sides in the other triangle. That's it for today. Till next time.